Uh, Good evening, everybody. So let us begin today's session. So, in week 10, Sir has covered these topics. Uh, Actually, not much is visible from this because it's written just part 1, part 2, part 3, part 4, part 5. But from this week onwards, okay, we are going into more advanced C++ features. So these were not part of the original C++ which was created. They have been recently added. So for this we'll go over the sir's slides. Wait a minute. Okay, it's visible to all, I guess. So I'll go. So this module is about three major things, which are auto decal type and suffix return type. So, we'll learn about these things. So mainly, see, what I understand is that auto is used when the type name is very long and we don't want to specify the type name, or it can be used where we do not like the exact type can be inferred and we do not care about the exact type name. For example, one common situation is when we are using iterators. When we are using iterators for containers, like let us say we are using map, or we are using pair, or we are using uh, set or something like this. Okay, so oftentimes what can happen is that when we use a iterator like m dot begin, here you can see that m is a map of integer and string. So you have the keys are integers and they point to strings. Okay, so and we want to iterate over this map. Let us say we want to print out all the keys in the map, or all the values, or we want to search in the map, something like that. So then we usually have to iterate. So to iterate, we write this thing. We write m dot begin, and we write m dot begin, and this m dot begin, it returns a pointer. I mean, not a pointer. It returns a iterator whose type is like this: std map int string iterator. So what can happen is that when we write, like if we did not have auto, then what would happen is that on the left, like to write the same expression on the left hand side, we would have to write this entire expression. So without auto, the same line will be written like this. Okay, so as you can see, first we'll have to write this big expression, and then we'll have to write I1 equal to m dot begin. So to avoid this, we can use auto, because here we don't care about the exact type of the iterator. We just want the iterator. Next, we go to decal type. So decal type is used when we want to get the type of a expression without evaluating it. Okay, so we want to get the type of the expression without evaluating it. This is especially useful when we are writing templates, because if we just write normal functions, then we know the type of everything. Okay, in case of auto, okay, we know the type, but we are just avoiding writing it. Okay, we are writing auto just so that it automatically fills in the type. Okay, but in case of decal type, it is primarily used in templates because the type may be unknown. I will show an example here. uh, yes, so this is a great example. So if we have a template class, okay, which accepts two different types, class T and class U. These are the template arguments, and we have the function where we accept two variables of two different types, and then we perform a operation x into y. Then what should be the output type? Okay, so this is bit ambiguous, because should the output type be T, or should it be U, or should it be something else? Okay, we like when we are writing this template code, we don't know, because our classes T and U, they can be anything. They can be int double, they can be double int, they can be some custom type with overloaded multiplication sign. So we cannot deduce the type of return type. So in these cases, we use decal type to calculate the type basically. Uh, it is something like this. Okay, decal type x into y. Although here x and y are not in scope, but you can understand that the syntax is somewhat like this: decal type, and in parentheses we write the expression. The expression is not evaluated, so x and y, they won't be multiplied, but the type of the expression is calculated, and that will be put in place of this decal type call. So so that is decal type. Now one important distinction. Okay, so this is an important thing to note. Okay, the auto keyword, it never deduces constness and references. Okay, so when we use auto, the const and references are not inferred, only the type is inferred. But when we use decal type, then the references and constness are also copied, basically put into the new variable. And next one is this one, suffix or trailing return type, which I already showed. What might happen is that when we are writing a template, we might not know the return type because there are two or three different classes involved. So over there we can use decal type in this manner to specify the return type, but this is not a good way of doing it. And you can also see this is very confusing. So this is a new piece of syntax which was introduced. We can, in place of the return type, we can write auto, and then we can put a arrow and we can write decal type x into y. So this is a new piece of syntax which was introduced. So this is known as the trailing return type. In C++14 this might be unnecessary. Like as you can see in C++14, the suffix type can be skipped and the return type is deduced automatically. So we can just write this. Okay, any questions on this one? Because like this module is over, so I'll go to the next one. So any questions? Okay, then let us go to the next one. Okay, so this module is about initializes lists and initialize a list, uniform initialization and range for statement. So first I would go over the range for statement because okay, so there is a question. Please could you remind us the difference between auto and decal type auto? Okay, so the main difference is that auto does not. So see, auto does not infer the constness and the uh, reference status, but the decal type it gets that also. Wait, let me. This is visible, right? So as you can see, we have a integer a, then we have a reference b, integer reference b, and then we have a constant integer and a constant integer reference. Constant integer and a constant integer reference. So now let us say we declare some new variables, a auto, b auto, c auto, d auto, uh, and we give the data type as auto, which means that the data type will be deduced automatically, and we set these to a, b, c, d. Now as you can see, a is of integer type, so it is integer. B is a integer reference, but it is still being set as integer because auto never deduces the CV qualifier or the reference. Yeah, C auto is also integer, D auto is also integer. Now when we come to decal type, uh, decal type, you can see that when we write decal type A B C D, so this is decal type A B C D. These are the, so what is the difference between these expressions and these expressions? So the first, the expression on the left, it is used to calculate what is the type going to be. So as you can see that a is a integer, so this expression will be replaced with int. B is a integer reference, so this whole expression will be replaced with int ampersand. Then decal type C, so C is a constant int, so this expression will be replaced with const int. So like that, and these are the new, this a underscore dt, b underscore dt, these are the new variables which we are declaring. So that is the difference between auto and decal type. Now in C++14 there is a new syntax called decal type and in parenthesis auto. So this simply means that we are not even specifying from where to calculate the type expression. Okay, for example here, okay, let me zoom in a bit. Okay, so for example in this case we could have written decal type and then c, we could have written decal type c b dt equal to b. So decal type c would yield constant, so this would become constant, and then b underscore dt equal to b. Now note that b is a integer reference, but it would be assigned to a constant integer called b underscore dt. So basically there are two things which we are specifying here. So when we write decal type auto, we omit the first one, so we don't specify from where to calculate the type. So we write decal type auto, then variable name equals to b, and from this RHS, it, from the right hand side, it calculates the type. So this is actually very similar to auto. Okay, so in case of auto also this happens. Okay, but the difference is that in this, if we write it like this, then the CV qualified and the reference is also added. So you can see the difference. When we write auto, then the types are calculated like all the types are int, but when we write decal type auto, the CV qualifier and the references are added here. Okay, so now the question is that why didn't we use decal type auto and then multiplication? Okay. Okay, so when you are saying this decal type auto, then so see it depends on what the language supports, right? So the if you see then the uh, so if you see then you can see that in C++11 this kind of syntax was introduced where we can write in C++11 this syntax was introduced where we can write auto and then after a right hand arrow we can write this decal type x into y, and then in C++14 so the language was upgraded so that this part of the syntax need not be specified. We can just write the expression and it would be calculated. And then you can see that C++14 also introduces decal type auto, which you are saying. So we can write here decal type auto and this. So this is similar to the this one and this one, they're similar except that in decal type auto the constness and the references will be taken care of. Okay, so Anuba, is it okay? Okay, okay. So see the okay, okay. So see what you're asking is why don't we use decal type auto? So it depends on what the language supports. So as you can see that earlier the C++ language did not support this, but then in C++11 this syntax was added. Let me erase everything. So in C++11 this syntax was added wherein we can write auto and then we can write decal type. So this part of the syntax was added in C++11. Then in C++14 the language was upgraded so that this part of the syntax need not be written. As you can see, just the auto part is written here. So it's like that. Then in C++14 it was again like it was also upgraded so that we can use decal type auto also. So as what you're saying, so decal type auto can also be used. So this and this auto and decal type auto they are very similar. Just the decal type auto it takes care of const and reference. Okay. So I'm then proceeding. Okay, so in this module, in this module, like this module covers initializer lists uniform initialization and range for statements. So I would go over the range for statements first because that is the easiest one. Okay, so a range for a statement is nothing but a simpler way to write this iteration syntax. So like if we want to, oftentimes we have to iterate over a container, like we have to iterate over a list or a vector, or let us say some map or some set, but the general syntax is something like I equal to 0, I less than v dot size and I plus plus, or it could be in the iterator way, it could be uh, p equal to v dot begin, p not equal to v dot end, and plus plus v. So instead of writing this, we can write a range for statement. Now this is a new syntax which has been introduced. So this is the range for syntax. So in range for syntax, we can write for, and then we can specify a data type, and then colon, and then the container which we are iterating over. For example, this is an example you can consider. For const auto x, and then we write colon, and then the list is given. So this is equivalent to writing for I equal to 0, I less than array size I plus plus, and then xi. I mean x equal to arr I. So that is just it. So this is the this is just a simple like shortening of the syntax. Any questions? Okay. Now I will go over the initializer list. So you might have seen this way of initialization where we write a vector and then in curly braces we give a list of values like this. So this like the values within the curly braces, this is known as a initializer list. So as you can see, it's written the mechanism for accepting curly braces list, so brace list, is a function of a constructor accepting argument of type std initializer list. Okay, so we can if you want to customize the behavior, then we can specify a constructor which uh, accepts this kind of a argument, and it does something, it does some custom processing. The initializer list class has these main member functions: size, begin, and end. Now it is a list, so it obviously should have the size, and it also has a pointer to the first element and a pointer to the last element. So as you can see here an example. So here we are writing a templated class. Okay, we are writing a templated class which has a vector called lms, and then we are specifying several constructors. One is the default constructor, one is a constructor with one integer, and one is a constructor with a initializer list, and the other one is a last one is a mixed type of constructor which has a integer and it has a initializer list also. So now you can see in the main class we can, I mean in the main function we can use these constructors as shown. So the first two, it is obviously known, you can just default constructor you can do it like this, and the constructor with the integer you can do like this. The constructor with initializer list you can do like this, but usually it is done like this. Okay, this is the proper way to use initializer list. So first we specify the class name and the variable name, and then in curly braces we give the list. So in curly braces we might write 1 2 3 4 5. To use the mixed kind of constructor we can follow this kind of syntax where we, in curly braces first we write, so see the constructor, mixed constructor, it takes a integer and then it takes a initializer list. So in curly braces first we can specify the integer and then the initializer list. So that is the basic thing about initializer list. So now as with any constructor the same kind of thing happens, there will be overload resolution and all. The next one is this uniform initialization. This is not any new topic, it is just that from C++11 uh, the initializer list syntax, so the curly braces syntax can be used to initialize anything. Okay, it can be used anywhere, it can be used to initialize anything. So the initialization syntax has become uniform. That is just what it means, that the initialization syntax has become uniform. For example, you can see that previously in C++03 there were multiple ways of initialization. Uh, you could use this parenthesis symbol, you could use equal to, you could use curly braces, uh, you can use curly braces again, and you can use parenthesis. For containers you can use this kind, like these kind of constructors, and member and heap arrays are not possible to initialize. But from C++11 and 14 we can also use the previous ways, but we can use the initialization list for everything. So here you can see here we have initialized two constant integers using the curly brace syntax. Here we have initialized an array, here we have initialized a struct, and then a pointer and another pointer, and then here we have initialized a vector. We are initializing a array, and you can also see that we can use the braced syntax while returning also. So if we have a function called point to make point, in the return, while returning the answer we can use the curly brace syntax to create a point to object and return it. So you can see here is return expression calls point to constructor. Without the initialization list we would have like this one, we'll have to write something like this. Sorry. Okay, so without the initialization list syntax, we would have to write this kind of a code. But with the curly brace syntax, we can just write return and then 00 in curly brace. So, so that is all for this module. I will go to the next module. Any questions? So this is the next module. So this module covers a lot of very small features. So none of these so all of these features are introduced in C++11, and all of these are very small features. Okay, so like even if they are large, they have been, I mean, covered in a short manner in this course. So we'll go over all of these features in this module. So the first one is okay. So the first one is very simple. It's called const expression. So it is used to calculate things at compile time. Like if a expression is, like if it can be deduced at compile time, we can force its deduction using const expression. Let me think of your example. Okay, so like let us say that we here we have defined a here we have defined a few enums. So we have defined a enum class called flags, where we have given good, fail, bad, and end of file. Then we write here const expression int operator. We are overriding the bitwise or operator. Okay, and then we are accepting two flags, flag f1 and flag f2, and then we are returning the basically the odd version. So we are doing bitwise or. First we are converting the flag into the integer, then we are performing bitwise or, and then we are converting the integer back into a flag. So that is what we are doing. Now here we have put here const expression. So it means that if the arguments are known at compile time, then the output is replaced in the function body. Wait a minute. So for example, let us say that in in our main function or in some other place, we write this expression const expression int x1 equal to bad or EOF. So this means that now if bad and EOF, they are also constant. Okay, if both of them are constants, then it means that this value will be calculated while the program is compiling. Okay, when the program is compiling, then this value will be calculated and it will be replaced here. Okay, so like bad is 2 and EOF is 4, so the bitwise odd of uh, 4 and 2 is 6. So this will be replaced with 6. So this expression will be removed and it will be replaced with 6. Okay, so that is what constant expression does. Now here you can see that we have a function here where we have written here const expression int x2 equal to bad or f3. Now this cannot be calculated in compile time. Why? Because we don't know the value of f3. Okay, so we don't know the value of f3, so we cannot calculate this. So this is a error. But the second line, this one is successful because this is not a constant expression. Okay, it's just a normal line. So here you can see the difference between constant expression and const. So when we declare something as const, it just expresses the idea that the object is not modifiable through an interface, but it can be modified through other interfaces. As you have seen that uh, we can do a const cast to remove the const and modify it. Okay, but so this is like the const thing. It just expresses the idea that the object should not be modifiable, and it also says that it declaring the object as const provides excellent optimization. Um, so you can see this one. If an object is declared as const and its address is not taken, then the compiler is often able to evaluate its initializer at compile time and keep that object in tables rather than emitting it into generated code, which means it is similar to constant expression. So if we are not using the address of a constant variable, then the all the calculation related to the constant variable, it can be calculated in compile time and it can be kept in tables instead of putting its code into the executable. uh, Whereas you can see in constant expression, its primary function is to extend the range of what can be computed at compile time and make such computation type safe and also usable. Objects declared constant expression have the initializer evaluated at compile time. So this is just it. Here it is like this is something else. So here is written constant expression and static. So what happens when we combine both of them? So static specifies the lifetime of the variable. So a static constant expression variable has to be set at compilation because its lifetime is the whole program. So this is a great example. Here you can see we have written here a function which calculates a factorial. Okay, it's a normal function. But you can see we have declared it as constant expression. And then here we write static constant expression auto for the data type and then magic value equal to factorial 5. So as you all know that factorial 5 is 120. Factorial 5 is 120, and now this is a constant value actually, and since it has been declared as a constant expression, this value will be calculated at compile time and it will be replaced here. So this one will be removed and it will be replaced with just 120. So you can understand that how much of a savings it will create at runtime. So when the program is running, it will not have to call this factorial function and perform the factorial. Now factorial might be a easy thing to do, but the initializer function might be quite big. So the thing is that if it is a constant expression, that can be avoided, and the and the final value can be put in its place like this. Um, no, it so Anuba has asked a question. So does this mean that in constant expression the evaluation of initializer value is guaranteed at compile time, but no such guarantee exists for constant? So it is not exactly that, because constant expressions can also be used with functions, as you have seen here. Okay, so how, like, it is not possible to do these kinds of things with const. Like, let us say that I erase all the markings. So how would you do this kind of a thing with a const? Like, you cannot do it, right? You cannot, like, although factorial 5 we know it is a constant, but we cannot replace it like this with just a const. I think what you're saying is correct, because in this slide it's written that if a object is declared as const and its address is not taken, then the compiler is able to evaluate its initializer at constant at compile time, and then it's written that though it is not guaranteed, and then the object is kept in the table instead of emitting its code. And for constant expression it is written that object declared constant expressions have their initializer evaluated at compile time. So I think there is a guarantee that for constant expressions the initializer will be calculated. But other than this also there are some other advantages. Okay, because see, you can see the first point, which says that it is to extend the range of what can be computed at compile time. Okay, it is to extend the range of what can be computed at compile time. If you come to the wait, if you come to this factorial example, okay, then we know that factorial 5 is a constant. Okay, but we cannot force its evaluation without the constant expression. Okay, here if we had written a const, uh, let us say we had simply written here const unsigned int factorial, then its factorial 5 it would not be calculated at compile time. When the program is running, then this factorial function would be called and its value will be calculated. But when we declare it as a constant expression, and when the factorial's argument is a constant, okay, if factorial's argument was a variable, then this optimization would not be done, because you don't know the value of the variable. But if the factorial's argument is also a constant, like in this case it's 5, then this expression it can be calculated at compile time, and this function call can be replaced with just a value. So that's a big optimization. So this whole thing will be replaced, and just it will be replaced with 120. So it's a big optimization. I'm proceeding. So here you can see it cannot be used for all functions. So in this function, we are accepting two vectors. Okay, so there is a question here. What would happen if we had written const in front of the curly brackets in the example? So you are saying over here, if we had written const. So so see, when we write const over here, that is for class functions. Like it is not for global functions. Like for global functions, this does not have any meaning. But for class functions, when we write this, it means that the function is not modifying the class. For example, we can use it with getter functions. So we can write here int get x const. Usually it is wait a minute. Yes. Usually it is like this. Okay. It means that the get x function, it does not modify the class. It just reads the class. So outside of a class context, it does not have a meaning. Can we write a getter function with constant expression? Like we can write here, but the argument has to be constant. Actually, I don't think so we can write, because when we write get x, let me erase this. Suppose let us say we write const expression. So you are saying something like this, but here the x value, it is not constant, right? It is not known. Here the value of x is not constant, it is not known. So that is why I don't think this will be allowed. You can see here that what kind of errors might happen. So here there is a function where we are accepting two vectors, and we are calculating a dot size plus b dot size. You can see that a dot size and b dot size, they are not compile time constant. Okay, so that is why this function cannot be a constant expression. However, there is another example given where it works fine, because here we are accepting fixed length arrays. So if you don't know, then array the array container, it is a fixed length array. So so that size is compile time constant. You have to see, like if Okay, so what you are written is that can I return 5 for instance? Yes, that is allowed. So that would work fine. See, you have to like when we are doing all when we are using constant expression, you have to just you have to see whether you can calculate the things while compiling. So when the program is compiling, uh, like without taking any user input, okay. So when the program is compiling, we cannot take any user input, right? So without taking any user input, can you determine the values of those expressions? So in case of array, you can see that first here we have defined a array of size 10. Then we have defined a array of size 20. So when we want to add the array size, we know that it is 30. So this is independent of any user input or output. So whatever we do, like independent of any input or output, the array size will be 10 plus 20, 30. So that we can use constant expression. Whereas in this case, if we had used vectors, now in vectors, if it was, you know, input dependent, like suppose first time we are, now see vectors, they are not fixed size containers, right? So no guarantee can be written. So since there is no guarantee about the size of the vector, the array sizes cannot be added in case of vectors. Since vectors are not like as I said, they are not. There is no guarantee about the size, so we cannot do a dot size plus b dot size at compile time. Okay, because we do there is no guarantee on the size. But for arrays, we know
Hello.
this. Yes, hello.
Sir, I want to ask some questions.
Okay, wait. Okay, so Anuga, so for arrays the size is known, so we can perform this calculation. Okay, so now Hannah Thakur, you can ask your question.
Sir, can you move to lecture number 26 slide?
Lecture number 26.
Yes.
26 would mean the
Typecasting.
previous weeks.
Yes, yes.
Okay, wait, I have to open it. 26 is which week?
Sir, sixth week.
Yes. Which page?
Sir, last, second last page. Sir, upcasting. Sir, above. Sir, yes, yes, this slide. Sir, in this slide, I know that what is upcasting and what is downcasting. Upcasting means when we are converting derived class object into uh, base class object, right?
Yes, yes.
Sir, in this example, uh, sir has upcasted base class object address of B to derived class object's address of B to base class object PA.
Wait.
And sir, and sir, how? So sir, I don't able to understand how PA pointer is accessing data A and how PA pointer is accessing data B. Like why data A is accessible, data B is not accessible.
Okay, so see up till here it is up till this line it is just initialization, right? Then
Sir, up till this line, A pointer PA equal to address of A, I understood that this is a pointer of class A, and B pointer PB equal to
Okay,
address of
so
B is a pointer of class B. I
okay,
know.
so
Through this pointer,
this till this line you understand, right?
yes, through A pointer we can access A class contents, and through B pointer we can access B class contents.
Okay, so
Sir,
till this
after
line
down,
you can you understand, right?
yes, after
So
upcasting,
so from
how
here,
data members are accessing, how we are accessing data members after upcasting.
okay, so from here, PA equal to ampersand B.
Yes, yes, this is upcasting I know, but how data members are accessible?
So see, PA is a pointer of
Class A type.
class A. Okay, PA is a
Yes, yes.
pointer of class A. So
Uh,
if we set it to any, so see, since it is a pointer of class A, it can only access data A.
sir,
Okay,
we all, sir, we always know that pointer of any type can point to same type of data.
yes,
Like integer pointer can point to integer data. Likewise, in classes also, it should happen that class A pointer can all point to class A object only. Why it is pointing to class B object through upcasting?
okay, so I understood. Okay, I'll explain it. Wait a minute.
And sir, why we need to do upcasting? Sir, internally I don't able to know what is happening.
Okay, so the situation was somewhat like this. Okay, we had this A class,
Yes,
and then we had a B class, and then B was derived from A,
yes,
right? And then we had A star PA,
yes.
and then we had B star PB.
PV, which is pointing to their respective class.
Yes, and then we set PA equal to ampersand B.
Yes. What does this mean?
Okay, so now see, one thing you said that
Like PB is containing like what is this means? I don't able to understand.
so one thing you said
Like
that
like
P
B is converted to pointer of type PA and then assigned to PA. This is
no, uh, you must understand that pointer is a pointer to a memory address. Okay, and that memory address can contain anything. So one thing you said that integer pointer can point to integer, double pointer
yes,
can point to double. So
point to double.
that is not necessarily true. Okay,
Sir, but this is the rule we have studied in pointers. Like if integer pointer is containing any address, at that address the value should be of integer type only.
no, it is not necessary. It is
Why?
it is interpreted as an integer, but it may not be a integer.
Means
I mean, based on the pointer's type, it is. So see, in
means
your
pointer can point to value of any type. Based on its type, it is interpreted at that in that data type.
yes,
Like if pointer integer pointer is pointing to double value. So double value is interpreted as integer,
yes. So
and that
if
value is represented as integer.
you look at your computer's RAM or memory, okay, it will be a stream of ones and zeros like this. So
Yes,
a
yes,
pointer is a pointer to memory address like this, okay, and
yes,
So based on the pointers type, the data is interpreted in that way. Like if you're if you're let us say that we have an integer pointer. So then starting from this address, we take we take let us say 4 bytes, and this is interpreted as an integer. Okay, these 4 bytes, they are then converted to an integer, and you get let us say 7. But if you use a double pointer and you point it to the same location, then it takes more bytes. Okay, it takes
So, so sir,
16
the
bytes.
value interpreted will be different.
Yes, it will
Like
be
we
different.
have a we are using double pointer to point to integer value,
Hmm.
and because of pointer is of double type, in that integer value is interpreted as double type.
Yes, this will.
So that integer, so the actual value of integer might be different because it is interpreted as double.
Yes, yes. This will be some random value. It might be 4536 2 point.
That is, sir. Okay, I understood, sir. So
So
it is
if
advisable that value pointed by an integer should be of same type, so that there should not be any mismatch.
Mhm.
Exact value should be pointed by the pointer.
Yes, yes.
That's why.
Yes.
So, sir, here also PA which is of class A type containing address of PB type means at address of B we have B class object. So that B class object is interpreted as A class object.
Yes, yes.
So, sir, what is this means? Can you elaborate?
Yes. So this is a special case. Okay. Sometimes it might be useful to do this. Okay. And this is a special case where it works because of the inheritance. So because of the inheritance, if you look at a B object, it will contain a A object first. So the B object, it will first contain a object, and then it will contain something extra, which is part of.
Something extra, yes, it is a object layout of derived class. Means
Yes,
it is
yes,
containing object of A and something extra which is its own member.
yes, yes.
Okay, this is the
So
object layout of derived class.
yes, yes. So now,
Okay,
now
okay.
if we have a pointer to B, okay, we might have a pointer to B. Okay,
Pointer pointer to A, sorry. Sir, pointer to A. PA is equal to address of B.
no,
Means
no.
pointer to A.
Let us say we have PB. Wait, wait. Uh, we have a pointer over here. Okay, let us say ampersand B. Okay, ampersand B, the address of B. So so when we assign this ampersand address of B to PB, then this address is interpreted as a B object. So we can access everything that B has. But when we assign.
Sir, don't understood, sir. Sir, we are assigning address of B to PA. Sir, B is larger in size and A is smaller in size.
Wait, wait.
So how address of B goes to PA?
All the addresses are of the same size, because
Sir, yes, yes, 8 bytes. All the addresses are of 8 bytes. But I don't able to understand that PA how B class object is converted to A class object.
it is not converted, it is interpreted.
Means PA is containing address of B class object,
Yes,
which is of A type.
which is of B
Sir, this
type,
is
but it
this
is.
is sir. I don't able to understand this contrasting features. PA is of one at one time. PA is of A type and containing address of B type.
So I explained over here na, that the underlying, like, the all the addresses, they are of the same size, and they
Sir,
can point
in
to.
case of built in sir, in case of built-in type, I understood that if we have double pointer and double pointer is pointing to integer value, that integer value will be interpreted as double value.
Yes, yes.
Okay, so here also we have uh, pointer to a class A, that is PA.
हम्म
विच इज कंटेनिंग एड्रेस ऑफ पीबी, मीन्स पीए के पीए जो एड्रेस कंटेन कर रहा है उस एड्रेस पे बी ऑब्जेक्ट है।
हाँ, बी ऑब्जेक्ट है।
उस बी वो बी ऑब्जेक्ट अब इंटरप्रेट होगा एज अ ए ऑब्जेक्ट,
हाँ
मतलब ए क्लास का ऑब्जेक्ट,
हाँ
क्योंकि पीए का टाइप
हाँ हाँ
क्लास ए है।
हाँ
तो इसका मतलब क्या हुआ सर कि बी बी क्लास का ऑब्जेक्ट इंटरप्रेट हो रहा है एज ए क्लास ऑब्जेक्ट।
हाँ
यहाँ
हाँ
तो हमने समझ लिया लॉस ऑफ, यहाँ तो हमने समझ लिया कि इंटीजर डेटा टाइप डबल डबल में वो हो रहा है, मतलब इंटरप्रेट हो रहा है, तो इसका मतलब कुछ बिट्स एक्स्ट्रा ऐड हो रही है, कुछ बिट्स एक्स्ट्रा ऐड हो रही है।
हम्म,
मगर इसमें क्या क्या कैसा वो होगा, मतलब किस तरीके से इंटरप्रिटेशन होगी।
इसमें कुछ ऐड नहीं होगा, इसमें सब्ट्रैक्ट होगा, क्योंकि ए ऑब्जेक्ट छोटा है बी से। सो so
अच्छा
when we interpret it as a object, then we can only access the a part.
ओके,
Okay, so this is
मीन्स
the
वी आर इंटरप्रेटिंग बी, मीन्स वी आर इंटरप्रेटिंग बी एज अ ए ऑब्जेक्ट, मीन्स बी के
हाँ
अंदर सिर्फ ए वाला पार्ट ही रह जाएगा, ए बी वाला पार्ट हट जाएगा।
हाँ हाँ। वो
अच्छा,
सी देखो,
ओके सर।
वो मेमोरी
सर
में
मतलब बी
रहेगा।
वाला पार्ट,
ये
बी
जो
वाला,
ये जो एक्स्ट्रा डेटा है ये मेमोरी में रह जाएगा, ठीक है। ये मेमोरी से तो हटेगा नहीं, बट क्योंकि हमारा पॉइंटर का टाइप ए है, सो वी कैन नॉट एक्सेस दैट।
ओके, बिकॉज पूरा बी ऑब्जेक्ट जो है ए क्लास के टाइप में इंटरप्रेट हो रहा है। ए क्लास के टाइप में इंटरप्रेट होने का मतलब है कि ए के सारे डेटा मेंबर्स जो बी के अंदर है वही एक्सेस हो पाएंगे,
हाँ हाँ, मतलब
और
तुम
जो बी का खुद का होगा वो
इसका
एक्सेस नहीं हो पाएगा।
ऐसा करने का मतलब ये है कि तुम बोल रहे हो कि मैं बस ए वाला पार्ट को ही देखूंगा।
अच्छा अच्छा, मतलब बी वाले ऑब्जेक्ट पे आकर के हम ये देख रहे हैं, हम बी वाले ऑब्जेक्ट को एक ही टर्म्स में देख रहे हैं
हाँ हाँ
कि उसके अंदर एक ए का कंटेंट है या नहीं, मतलब बी के अंदर हम सिर्फ ए को ही खोज रहे हैं, ए का ही कंटेंट देख रहे
हाँ
हैं। ओके, सो रेस्ट ऑफ द कंटेंट विल नॉट बी एक्सेसिबल, मींस
हाँ
गिव्स एरर।
हाँ
एंड सर अगर इसका हम दूसरी स्लाइड पे अगर हम जाएं तो उसमें एक डाउन कास्टिंग का एग्जांपल है, आप इसको एक बार देखिए। उसमें सर
हाँ
क्या हो रहा है
उसमें
उसमें बता दीजिए थोड़ा।
हाँ, वो याद है
सर
मुझे।
उसमें हो रहा है पीबी इज इक्वल टू एड्रेस ऑफ
हाँ,
ए बी पॉइंटर।
तो उसमें कुछ ऐसा हो रहा है कि पी
सर
बी इक्वल
पीबी
टू
इज इक्वल टू
एम्परसेंड ए।
एड्रेस ऑफ ए।
हाँ
हाँ सर, इसमें अब इसमें क्या होगा कि जो बी क्लास का पॉइंटर है वो ए क्लास के ऑब्जेक्ट को, जो वो कंटेन कर रहा है ए क्लास के ऑब्जेक्ट को बी के टर्म्स में देखेगा।
हाँ हाँ
तो सर ए क्लास के ऑब्जेक्ट को वो बी के टर्म्स में देख रहा है, तो उसका मतलब उसके अंदर कॉमन जो चीज है बी क्लास और ए क्लास के अंदर, वो एक्सेस करेगा ही करेगा। मगर जो
हाँ,
ए क्लास के ऑब्जेक्ट को बी टर्म्स में देख रहा है, तो वो जो एक्स्ट्रा चीज होगी वो गार्बेज वैल्यू क्यों दे रही है, मतलब डेटा बी
क्योंकि
गार्बेज वैल्यू क्यों दे रहा है डेटा बी।
वो है ही नहीं। मतलब ये तो एक्चुअली तो ये ए टाइप का ऑब्जेक्ट है, बट अगर हम लोग इसको बी के तरह देखें तो ये एक्स्ट्रा वैल्यूज तो है ही नहीं। मतलब ये
सर एक्स्ट्रा वैल्यू तो आएगी ना सर, जैसे ए क्लास का ऑब्जेक्ट है, इसको अगर हम बी के टर्म्स में देखें
हम्म,
तो सर
हाँ,
बी
एक्स्ट्रा
के
वैल्यूज
टर्म्स में
आएगा।
देखने पे,
एक्स्ट्रा वैल्यूज तो फिर देखेंगे ना, बट वो इनिशियलाइज नहीं हुआ, या कंस्ट्रक्टर के थ्रू नहीं गया।
क्यों सर, कैसे कंस्ट्रक्टर के थ्रू नहीं गया।
क्योंकि देखो, हम लोगों ने बी बी ऑब्जेक्ट तो कंस्ट्रक्ट नहीं किया था ना। वी वी क्रिएटेड अ ए ऑब्जेक्ट एंड देन
नहीं
ऐसी।
सर, एग्जांपल में दोनों दोनों ऑब्जेक्ट कंस्ट्रक्टेड है, बी भी कंस्ट्रक्ट है और ए भी कंस्ट्रक्टेड है।
दोनों अलग अलग ऑब्जेक्ट होगा।
हाँ सर, दोनों अलग अलग कंस्ट्रक्टेड है।
तो वो तो कहीं और होगा ना, तो जो बी वाला ऑब्जेक्ट है वो कहीं और होगा मेमोरी में।
हाँ, बी वाले ऑब्जेक्ट का एड्रेस कुछ और होगा, ए का कुछ और होगा। तो
अरे
सर
देखो,
ये तो
बेसिकली
मेरे को
बेसिकली देखो, चीज है कि तुम तुम एक बड़ा ऑब्जेक्ट में से छोटा वाला पार्ट देख सकते हो, देन इट विल बी वैलिड। बट तुम छोटा ऑब्जेक्ट में तुम बड़ा कैसे देख सकते हो?
तो सर यहाँ पे हम जो पीबी इक्वल टू एड्रेस ऑफ ए कर रहे हैं, तो हम बड़े ऑब्जेक्ट में छोटा ऑब्जेक्ट देख रहे हैं ना।
नहीं, इसमें ए छोटा ऑब्जेक्ट है ना, ए छोटा ऑब्जेक्ट है,
हाँ।
उसको हम लोग बड़ा टाइप में डाल रहे हैं। तो
अच्छा मतलब हम।
सिचुएशन कुछ ऐसा हो रहा है, ए तो बेस क्लास है, मतलब
हाँ।
बी में एक्स्ट्रा चीजें हैं कंपेयर टू ए, और ए छोटा
हाँ।
क्लास है। तो हम लोग
हाँ।
छोटा
बड़े में
को,
छोटा डाल रहे हैं,
हाँ
बड़े में छोटा डाल रहे
हाँ हाँ, तो ये जो बाकी सारा मेंबर्स है, ये
हैं। हाँ।
इनिशियलाइज नहीं हुआ, इसलिए गार्बेज वैल्यू आ रहा है।
तो सर ये इनिशियलाइज कैसे नहीं हुआ सर? इसको तो दोनों ऑब्जेक्ट्स को तो हमने सेपरेटली पहले क्रिएट कर ही लिया है मेमोरी के अंदर।
तो वो तो हो गया ना, ये तो अलग ऑब्जेक्ट है। मतलब मेमोरी में कुछ ऐसा है जो दूसरा ऑब्जेक्ट को इनिशियलाइज किए थे, वो तो कहीं और है।
सर सर ये दूसरा ऑब्जेक्ट जो इनिशियलाइज करा था वो कहीं और कैसे? वो बी के अंदर ही तो होगा। बी के ऑब्जेक्ट के अंदर ही, बी ऑब्जेक्ट के अंदर ही तो होगा सर। डेटा बी बी ऑब्जेक्ट के अंदर ही तो होगा।
देखो देखो, तुम अगर कुछ ऐसा करोगे, ठीक है, लेटस से लेटस से तुम पी ए इक्वल टू एम्परसेंड बी कर रहे हो, ठीक है,
Yes.
एंड देन ऐसा कर रहे हो, पी ए इक्वल टू पी बी इक्वल टू पी ए कर रहे हो, ठीक है, लेटस से ये दो लाइन एग्जीक्यूट किए। तो इससे क्या होगा कि बी टाइप के ऑब्जेक्ट को फर्स्ट यू आर सीइंग इट एज अ ए टाइप ऑब्जेक्ट, ठीक है।
बी
सो
टाइप के ऑब्जेक्ट को हम ए के टर्म्स में देख रहे हैं।
हाँ, तो बड़ा ऑब्जेक्ट का छोटा वाला पार्ट देख रहे हैं, तो उसमें कोई प्रॉब्लम नहीं
हाँ तो
होगा।
हाँ बड़े ऑब्जेक्ट का छोटा वाला पार्ट देख रहे हैं। तो उसके अंदर जो कॉमन चीजें हैं दोनों के अंदर,
हम्म।
अगर हम दोनों को सेट मान लें, बी ऑब्जेक्ट को सेट मान लें और ए ऑब्जेक्ट को सेट मान लें, तो दोनों का अगर हम डिफरेंस करें तो हमें कॉमन पार्ट मिलेगा। तो वो कॉमन पार्ट हम देख रहे
हाँ, एंड देन ये जो सेकंड लाइन है जिसमें कर रहे पी बी इक्वल टू पी ए,
हैं। हाँ
इसमें,
डाउन कास्टिंग जिसमें कर रहे हैं तो।
हाँ, डाउन कास्टिंग कर रहे। तो इस स्पेशल केस में ये वैलिड होगा, क्योंकि तुम फिर से वही एड्रेस, मतलब वही वाले ऑब्जेक्ट को तुम फिर से बड़ा करके देख रहे हो, क्योंकि
सर पहले पहले केस में तो हम बड़े वाले ऑब्जेक्ट को छोटे के टर्म्स में देख रहे हैं।
हम्म।
तो वो जो बड़े वाले ऑब्जेक्ट का जो एक्स्ट्रा पार्ट होगा वो तो एक्सेस हो नहीं पाएगा।
हाँ
क्योंकि बड़ा और छोटे के बीच में जो ओवरलैपिंग रीजन है वही हम देख पाएंगे।
हाँ।
ठीक है। मगर ये जो है सेकंड वाला डाउनकास्टिंग एग्जांपल, इसमें हम क्या कर रहे हैं? जो आपका छोटा वाला उसको बड़े के टर्म्स में देख रहे हैं।
हाँ
तो इस केस में हम डेटा बी को एक्सेस तो कर पा रहे हैं, मगर जो सर इसमें हम छोटे वाले को बड़े के टर्म्स में देख रहे हैं। सर इसमें ये समझ नहीं आ रहा सर।
अरे देखो, तुम्हारा कंप्यूटर मेमोरी कुछ ऐसा है, ठीक है। अब उसमें तुमने
हम्म।
तुमने एक ऑब्जेक्ट बनाया जो ए टाइप का है, ठीक है, ऐसा कुछ,
हम्म।
और फिर तुमने एक और ऑब्जेक्ट क्रिएट किया जो कि बी टाइप का है, ठीक है।
हाँ।
बट वो कहीं और क्रिएट होगा, ठीक है, वो कहीं और क्रिएट होगा, और ये बी टाइप का ऑब्जेक्ट के अंदर एक ए टाइप का होगा जो कि बेस
हाँ अब
क्लास का है।
डाउन कास्टिंग करने पे ऐसा हो गया।
नहीं नहीं, ये तो ऐसा ही रहेगा ना, मतलब क्योंकि बी डिराइव्स फ्रॉम ए, सो एवरी बी ऑब्जेक्ट विल कंटेन एन ए
हाँ
ऑब्जेक्ट।
हाँ सर ओके 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 अंडरस्टूड अंडरस्टूड। हाँ
ओके,
ओके सर।
so अब upcast when you upcast, then you look at this address as a type object, you look at the b object as a type object, so so
तो
this is,
ओवरलैपिंग फीचर तो देखेंगे।
हाँ, तो ये वैलिड है क्योंकि you are seeing a small part of the big object, but when you
हाँ बिग
downcast
ऑब्जेक्ट का स्मॉल पार्ट देख रहे हैं।
but
तो एक्स्ट्रा पार्ट एक्सेस नहीं होगा।
when you downcast, you are seeing the small object as a big object, okay, something like this. using the small object as a big object. And so this is not
Hmm.
allowed now, because this, what about this extra portion? So this is not initialized. That is why उसमें garbage value है.
सर आपने यहाँ पे डायग्राम बनाया है एक्स्ट्रा, इस एक्स्ट्रा डायग्राम को ये जो सेकंड वाला डायग्राम है इसके अंदर देख सकते हैं एक। अब सर इस वाले डायग्राम में अगर हम देखें जो आपने सेकंड वाला बनाया है जिसके अंदर ए कंटेन है बी के अंदर
हम्म.
अंदर, तो सर इसके अंदर ए वाले पार्ट को अगर हम देखें, ए वाले पार्ट के अलावा जो एक्स्ट्रा पार्ट है वो तो बी का पार्ट है ना, और
हाँ.
उसको मेमोरी मिल चुकी है,
हाँ.
तो वो गार्बेज वैल्यू क्यों दे रहा है, उसको तो मेमोरी मिल चुकी है यहाँ पे बी वाले पार्ट पे।
तो वो तो नहीं देना चाहिए garbage value.
तो
एक
सर
मिनट.
आउटपुट उसमें गार्बेज वैल्यू दिखा रहा है।
एक मिनट मुझे देखने दो.
पहले केस में तो एक्सेसिबल नहीं होगा, ये समझ में आता है अप कास्टिंग में, डाउन कास्टिंग में वो गार्बेज वैल्यू दे रहा है एक्सेसिबल होने के बाद भी। हम सर स्मॉलर ऑब्जेक्ट को इन टर्म्स ऑफ बिगर ऑब्जेक्ट देख रहे हैं।
अरे तो वही तो बता रहा हूँ. लाइक ये है फर्स्ट स्लाइड में जो हो रहा है, जो कि है अपकास्टिंग,
ओके।
और ये है
तो सर
डाउनकास्टिंग.
इस ये जो फ्लश, मैं सर ये बोल रहा हूँ कि फर्स्ट स्लाइड को ही अगर हम डाउन कास्टिंग एग्जांपल के तौर पे देखें कि ए क्लास जो है उसको हम इन टर्म्स ऑफ बी देख रहे हैं, तो ए का कंटेंट तो हम एक्सेस कर ही पाएंगे, साथ में बी का कंटेंट भी तो एक्सेस कर पाएंगे ना, क्योंकि ए को हम बिगर पिक्चर में देख रहे हैं, स्मॉलर ऑब्जेक्ट को इन टर्म्स ऑफ बिगर ऑब्जेक्ट देख रहे हैं।
बट फिर गार्बेज वैल्यू आएगा ना.
तो सर बी तो ऑलरेडी, बी की बाउंड्री सेट है ना, बी की बाउंड्री तो ऑलरेडी सेट है, तो उसके अंदर जितनी भी डेटा मेंबर्स होंगे उनको ऑलरेडी मेमोरी
हाँ,
एलोकेट
वो
हो चुकी होगी ना।
सी देखो, वो केस में कुछ होगा नहीं, मतलब एक्चुअली मैं समझ नहीं पा रहा हूँ कि तुम कौन से स्लाइड का बात कर रहे हो.
सर स्लाइड नंबर लास्ट, डाउन कास्टिंग वाली। सर मैं फर्स्ट स्लाइड की बात कर रहा हूँ सर, ये जो आपने अभी इस डायग्राम में फर्स्ट स्लाइड बनाई है ना,
हाँ.
इसको मैं एज अ डाउन कास्टिंग एग्जांपल बोल रहा हूँ। इसी में अगर हम डाउन कास्टिंग को देखें तो ए डाउन कास्टिंग का मतलब क्या हो गया, स्मॉलर ऑब्जेक्ट को हम इन टर्म्स ऑफ बिगर ऑब्जेक्ट देख रहे हैं।
हाँ.
तो सर स्मॉलर ऑब्जेक्ट को अगर हम बिगर ऑब्जेक्ट के टर्म्स में देख रहे हैं तो उसका मतलब हो गया कि स्मॉलर ऑब्जेक्ट प्लस समथिंग एक्स्ट्रा।
हाँ.
तो सर स्मॉलर ऑब्जेक्ट के कंटेंट्स तो हम एक्सेस कर ही पाएंगे, तो बिगर ऑब्जेक्ट के कंटेंट्स भी हम एक्सेस कर पा रहे हैं, मगर वो जो उसकी वैल्यू ऑलरेडी बिगर ऑब्जेक्ट में सेट हो रखी थी,
हम्म.
दैट इज 5 और 3, वो ना होकर के गार्बेज वैल्यू क्यों आ रही है, क्योंकि
वो
उसको तो
वैसा
ऑलरेडी मेमोरी मिल चुकी है।
वैसा नहीं हो रहा है. मतलब देखो तुम, इस केस में ओके, लेट अस से ये राइट, ये जो दाहिने तरफ है वो वाला केस देखते हैं. सो इसमें इसमें मान लो तुम पहले तुम अपकास्ट कर दिए, ठीक है. सो बड़े ऑब्जेक्ट को तुम छोटे के फॉर्म में देख रहे हो, एंड देन लेट अस
हम्म,
से तुमने इसको रिवर्स कर दिया, तुम फिर से वही एड्रेस को तुम बी के टर्म्स में देख रहे हो. सो उसमें गार्बेज वैल्यू नहीं आएगा. ओके. उसमें मतलब नॉर्मल वैल्यूज आएगा, ऐसे गार्बेज वैल्यूज नहीं आएगा. बट ये वाला केस स्लाइड में नहीं दिया है.
अच्छा जो मैं केस बोल रहा हूँ वो इसका अपकास्टिंग का रिवर्स होगा,
हाँ.
वो डाउन कास्ट। सर अपकास्टिंग का रिवर्स फिर होगा कैसे, तो अपकास्टिंग का रिवर्स जस्ट इसमें लिखा है कि पी ए इक्वल टू एड्रेस ऑफ बी, तो सर इसका रिवर्स क्या क्या होगा,
देखो पहले.
जैसे अपकास्टिंग में तो होगा ना पी ए इक्वल टू एड्रेस ऑफ बी, तो जो मैं केस कह रहा हूँ रिवर्स, तो वो होगा कैसे, तो सर वो ऐसे ही तो होगा, पॉइंट पी बी इक्वल टू एड्रेस ऑफ ए।
हाँ, बट वो स्पेशल केस है ना, क्योंकि बी के लिए ऑलरेडी मेमोरी एलोकेट हो गया है. वो इन जनरल नहीं होगा.
हाँ सर बी के लिए तो मेमोरी एलोकेट हो गया है, मगर ये सर समझ नहीं आ रहा है कि ये जो है,
तो पहले पहले हम लोग अपकास्ट कर रहे हैं। ठीक है, तो ये है अपकास्टिंग।
यस, डिराइव क्लास के ऑब्जेक्ट को बेस क्लास में डाल।
हाँ, फिर उसके बाद तुम सेम एड्रेस को, ठीक है, सेम एड्रेस को अगर डाउनकास्ट करोगे, लेट अस से ऐसे करके।
हम्म। तो सर अब हम इसमें बिगर ऑब्जेक्ट को इन टर्म्स ऑफ स्मॉलर ऑब्जेक्ट देखें, तो सॉरी स्मॉलर ऑब्जेक्ट को।
ओके, सो पहले हम लोग अपकास्ट कर दिया ऐसे, फिर हम लोगों ने डाउनकास्ट कर दिया ऐसे। ठीक है, और
हम्म।
इसमें एड्रेस सेम है, तुम अगर तीनों को प्रिंट करोगे तीनों का वैल्यू सेम आएगा। लाइक तुम पी ए को प्रिंट करोगे, पी बी को प्रिंट करोगे, थ्रू आउट दिस ऑपरेशन सबका वैल्यू सेम आएगा, क्योंकि वो सेम
क्यों
लोकेशन
सर?
को देख रहा है।
सर पी ए जो है वो एड्रेस ऑफ बी कंटेन कर रहा है, पी बी जो है वो एड्रेस ऑफ ए कंटेन कर रहा है।
हाँ, दोनों सेम है, क्योंकि
कैसे सर?
क्योंकि मेमोरी में सेम लोकेशन पे है। ये ये एरो देखो ना, ये सेम लोकेशन पे ही है।
सर ये तो लोकेशन के इनर लोकेशन में है ना, तो
वो
लोकेशन का अलग अलग तो वो नहीं होगा
नहीं नहीं,
डिफरेंस?
वो ड्राइंग थोड़ा अलग है, बट ये बी के अंदर सबसे पहले ए रहता है। ठीक है, ऐसा कुछ होगा। तो
सर
तुम प्रिंट करोगे तो पी ए पी बी सब सेम आएगा, ये तीनों लाइन में।
सर ओके, क्यों सर?
अरे क्योंकि ये एरो सेम लोकेशन पे पॉइंट कर रहा है ना।
सर ये एरो कौन सा पॉइंटर है? पी ए?
सबका वैल्यू सेम ही है, तो कुछ भी हो सकता है, पी ए पी बी, पी ए
अच्छा,
पी बी।
मतलब ये दोनों एक दूसरे के एड्रेसेस कंटेन कर रहे हैं। पी
हाँ
ए पीबी का एड्रेस कंटेन कर रहा है, पीबी पीए का एड्रेस कंटेन कर रहा है, इसलिए एड्रेसेस सेम है।
हाँ हाँ।
अच्छा अच्छा, ठीक है सर। जैसे एक पॉइंटर दो। ओके ओके।
तो इस केस में तुम पहले बी ऑब्जेक्ट को अपकास्ट कर दिए, और उसके बाद सेम एड्रेस को तुम डाउनकास्ट कर दिए। सो इस केस में,
हेलो।
हेलो।
हाँ सर। हाँ सर, मगर ओरिजिनली जब ये ऑब्जेक्ट सेपरेटली क्रिएट हुए होंगे मेमोरी में, तो उनके एड्रेसेस अलग अलग होंगे ना तब तो?
नहीं नहीं, ये ओरिजिनली अलग अलग क्यों क्रिएट होगा?
सर उस स्लाइड के अंदर पहले सर ने जो है ऑब्जेक्ट को सेपरेटली क्रिएट करा है, पीए पॉइंटर को अलग क्रिएट करा है, ऑब्जेक्ट ए को अलग क्रिएट करा है, ऑब्जेक्ट ऑफ क्लास बी को अलग क्रिएट करा है, फिर उनको उनकी रेफरेंसिंग कराई है पी ए पी बी के साथ।
तो हाँ देखो ना, ये तो अलग हो गया ना। एक ऑब्जेक्ट यहाँ पे बना, दूसरा इधर बना, तो
हाँ
दोनों अनरिलेटेड है।
हाँ, अभी अनरिलेटेड है। ओके सर, अंडरस्टूड। सर मतलब ऐसा हो रहा है कि एक ऑब्जेक्ट को दूसरा पॉइंटर पॉइंट कर रहा है, और दूसरा
हाँ
पॉइंटर भी फिर उस फर्स्ट ऑब्जेक्ट को पॉइंट कर रहा है।
हाँ हाँ। तो देखो इस केस में लेटस से तुम ऐसा करते हो, पहले अपकास्टिंग करते हो, फिर सेम एड्रेस को डाउनकास्ट करते हो। ओके, इन दैट केस गार्बेज वैल्यू नहीं आएगा, क्योंकि बी का एलोकेट हो गया है। ठीक है,
तो सर उसमें तो स्लाइड में डाउन गार्बेज वैल्यू लिखा
तो
है।
स्लाइड में ये केस है ही नहीं।
सर है, मैं आपको दिखाऊंगा, आपको देखो आप एक बार।
नहीं, स्लाइड में ये केस है ही नहीं।
सर गार्बेज वैल्यू है सर डाउन कास्टिंग वाले एग्जांपल में, जिसमें लिखा है सर पोस्ट डाउन कास्टिंग।
हाँ, वो दूसरा केस है, वो ये बाएं तरफ वाला केस को दिखा रहा है।
तो सर ये वही तो केस है सर डाउन कास्टिंग वाला।
नहीं, ये अलग है, क्योंकि इसमें तुम सेम एड्रेस को पहले अपकास्ट कर रहे हो, फिर डाउनकास्ट कर रहे हो।
ओके ओके ओके।
मतलब तुम अगर ऐसे करोगे, पहले अपकास्ट करोगे फिर सेम चीज को डाउनकास्ट करोगे, तो कोई गार्बेज
मतलब
वैल्यू
पी
नहीं आएगा।
मतलब पीए को मैंने पहले अपकास्ट कर दिया, फिर पीए को ही मैंने डाउनकास्ट कर दिया।
हाँ, तो उस केस में गार्बेज वैल्यू नहीं आएगा।
अच्छा, तो
नहीं,
सर यहाँ पे डिफरेंस क्या हुआ? पीए पीए की जगह मैं एड्रेस ऑफ ए लिख देता हूँ, तब वो डाउनकास्टिंग होगा। यहाँ पे सेकंड वाली लाइन में, लास्ट वाली लाइन में अगर मैं पीए की जगह एड्रेस ऑफ ए लिख देता हूँ, तब वो डाउनकास्टिंग कहलाएगा, फोर्स्ड डाउनकास्टिंग।
ये भी फोर्स की है, बट ठीक है, बट वो
सर
अलग
दोनों
ऑब्जेक्ट हो
सर
जाएगा।
तो सर दोनों एक ही बात ही तो है। पीए मीन्स पॉइंटर टू ऑब्जेक्ट ए, एंड एड्रेस ऑफ ए मीन्स पीए ओनली। तो सर उस केस में गार्बेज वैल्यू दे रहा, तो इस केस में भी गार्बेज वैल्यू देना चाहिए।
नहीं, ये देखो, ये जो पी ए, अरे ये लाइन बाय लाइन पर हो ना, तो पी ए जो है, ये तो ये तो पी बी का एड्रेस होल्ड कर रहा है।
हाँ,
मतलब इधर लाइन बाय लाइन देखो ना, तो पी ए तो एक्चुअली एम्परसेंड पी बी है।
ओके ओके ओके। रुको रुको।
ये वाला केस स्लाइड में दिया नहीं है।
तो सर इसमें पीए को हम बी में कास्ट कर रहे हैं एक्सप्लिसिटली, बी पॉइंटर में। तो सर पीए के अंदर ऑलरेडी अगर बी का एड्रेस है, तो उसको हम बी में कास्ट क्यों कर रहे हैं बी पॉइंटर करके?
बस उसे रीइंटरप्रेट कर रहे हैं।
क्यों सर ऐसा क्यों कर रहे हैं? वो तो ऑलरेडी बी का एड्रेस कंटेन कर रहा है पी
वो
पीए।
एड्रेस तो सेम ही है, मैं बोल रहा हूँ ना, तुम प्रिंट करोगे पी ए पी भी सेम ही एड्रेस आएगा, बट उसका इंटरप्रिटेशन अलग कर।
मतलब पीए का टाइप हम चेंज कर रहे हैं।
वो वो जो नंबर है, वो नंबर सेम रखे। तुम अगर सी आउट पी ए पी बी करोगे, तो दोनों सेम ही आएगा। दोनों लेटर
हाँ
से ऐसा
सर ये
कुछ 1 2 3 4 5 आएगा दोनों। तो ये एरो का लोकेशन सेम है, बट हम लोग इंटरप्रेट कर रहे हैं अलग तरीके से कि वो एरो
अगर
को।
सर पीए पीए की जगह एड्रेस ऑफ ए कर दे तो
कौन से लाइन में? इसमें
लास्ट वाली लाइन में, हाँ।
एड्रेस ऑफ ए, बट फिर एड्रेस ऑफ ए ये वाला हो जाएगा। मतलब भाई इसमें ऑब्जेक्ट
ओके।
का नाम नहीं लिखा है। एक मिनट, स्लाइड में क्या दिया है? स्लाइड में स्मॉल ए कैपिटल ए दिया है ना, तो स्लाइड में ये स्मॉल बी है, और ये कैपिटल स्मॉल ए है, और ये है ए टाइप का ऑब्जेक्ट, और ये है बी टाइप
बी
का
टाइप।
ऑब्जेक्ट। तो
सर
इसके
पी
अंदर ए टाइप। ठीक है, मैं फिर कंटिन्यू करता हूँ।
हेलो
हेलो।
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 सर डाउट क्लियर नहीं हुआ है सर अभी। सर एक
हाँ।
चीज पूछनी थी सर, ये जो पीए है, ये एड्रेस ऑफ बी कंटेन कर रहा है, मतलब ये
हाँ।
बी को पॉइंट कर रहा है।
हाँ।
तो बी को पॉइंट करते हुए ये एक बी को एज अ ए इंटरप्रेट कर रहा है, ए की
हाँ।
टर्म्स में इंटरप्रेट कर रहा है।
हाँ।
और सर जो लास्ट वाली लाइन है उसके अंदर पीए जो है वो अपने वैल्यू से नहीं, अपने टाइप से इंटरप्रेट हो रहा है। उसका टाइप जो है वो क्लास बी में कन्वर्ट हो रहा है।
हाँ।
अच्छा, ऐसा हो रहा है सर।
हम्म।
और सर यहाँ पे पीए की जगह अगर एड्रेस ऑफ पे कर देंगे तो वो ये वाला केस बन जाएगा, सेकंड स्लाइड वाला।
हाँ वो फिर तुम अगर इधर एड्रेस ऑफ ए करोगे तो ए तो अलग लोकेशन पे, तो ये एरो दूसरा हो जाएगा।
ओके।
उस केस में गार्बेज वैल्यू आएगा क्योंकि उस लोकेशन पे मतलब इनिशियलाइज नहीं हुआ।
उस लोकेशन पे उस लोकेशन पे जो बी, मतलब उस लोकेशन पे हम बी के टर्म्स में जब देखेंगे ए को, तो
हाँ
बी वाला बी वाला आउटर बाउंड्री जो है उसमें कुछ इनिशियलाइज नहीं हुआ होगा
हाँ
इसलिए।
हाँ।
ओके सर, एंड सर 1 मिनट सर, एक डायग्राम बना लो सर इसको। सर हेलो।
हेलो हाँ।
सर जब हम ड्राइव ड्राइव क्लास के एड्रेस को, ड्राइव क्लास के ऑब्जेक्ट को न्यू पॉइंटर के थ्रू, न्यू ऑपरेटर के थ्रू क्रिएट करवा के बेस क्लास के ऑब्जेक्ट को असाइन करवाते हैं,
हाँ
तो वो भी एक तरीके की अपकास्टिंग है।
हाँ हाँ
जैसे बेस क्लास के ऑब्जेक्ट के
हाँ,
अंदर
वो
हमने
सेम ही है।
न्यू न्यू ड्राइव क्लास ऑब्जेक्ट असाइन करवाते हैं,
हम्म।
तो वो भी अपकास्टिंग है। तो उसमें भी जो डेटा मेंबर्स एक्सेस होंगे वो इसी पिक्चर के थ्रू एक्सेस होंगे कि उस पॉइंटर के थ्रू हम
हाँ
जो
सेम
है
है सेम।
उस ऑब्जेक्ट के टर्म्स में हम स्मॉलर ऑब्जेक्ट को देख रहे हैं।
हाँ ऐसा बात करो ना, पी ए इक्वल टू न्यू बी।
नो सर, सर जैसे ए क्लास का ऑब्जेक्ट है ए, सर जैसे ए,
यही
कैपिटल
तो
ए,
बोल रहे हो ना ये।
सर
न्यू बी ये डिराइव्ड
सर
क्लास, इसको बेस क्लास के पॉइंटर पे।
नहीं सर, सर पी ए की जगह अगर हम लिखे कैपिटल ए और स्मॉल ए,
पी ए की जगह कैपिटल ए।
स्मॉल ए
अच्छा अच्छा।
मीन्स पॉइंटर के थ्रू अब नहीं होता है सर, हम
अरे
एक्चुअल
बट वैसा
ऑब्जेक्ट के थ्रू
वैसा नहीं
ये
होता है।
करवा रहे हैं।
ये नहीं होता, न्यू न्यू वाला ये तो पॉइंटर देता है।
सर ऐसा मैंने देखा है कई बार कि ड्राइव क्लास का ऑब्जेक्ट हम न्यू ऑपरेटर के थ्रू क्रिएट कर रहे हैं मगर असाइन उसको बेस क्लास के ऑब्जेक्ट
हाँ
में करवा रहे
बट जो न्यू ऑपरेटर है वो पॉइंटर रिटर्न करता है।
हैं। हाँ, तो ये पॉइंटर रिटर्न करेगा और कोई भी ऑब्जेक्ट वो इटसेल्फ पॉइंटर होता है।
तो इस केस में ए स्टार होगा, ए स्टार ए होगा।
तो सर ये अपकास्टिंग का एग्जांपल है।
हाँ हाँ।
ओके, तो वहाँ पे ड्राइव क्लास का ऑब्जेक्ट को हम एक ही टर्म्स में देख रहे हैं, ऐसा है ना सर?
हाँ हाँ
मीन्स हम बिगर ऑब्जेक्ट को स्मॉलर ऑब्जेक्ट की तरफ ही देख रहे हैं, तो वो कॉमन वाला पार्ट हम देखेंगे तो एक्स्ट्रा वाला पार्ट हट जाएगा, एक्सेस नहीं हो पाएगा।
हाँ।
ओके सर, थैंक यू सर।
Okay, so this was constant expression. So the next one is no except. So this is added to a function to to signify that the function does not throw an exception. Like
Sir,
we
which week is this?
this is week 10.
Sir, this week is the beginning of modern C++.
Yes.
Okay.
Okay. So if we have a function and we put no except, then the function is not allowed to throw an exception. If it throws an exception, then the program crashes. So the program is terminated by a call to std terminate. Next, one more feature that was added to C++ is null pointer literal. So as you might remember
Hello.
in original C, yes,
Sir, can I ask doubt whenever required?
yes, yes.
Apart from this video, with this video session,
Okay.
like personal video session with you,
Uh,
where I share my screen and you and me only, because I have some several doubts from past weeks.
okay, okay.
So, sir, when we you will be available for that?
Are you in the group?
Yes, yes.
Okay, so message me on WhatsApp.
My doubt, I will message you on WhatsApp.
Yes, yes.
Okay. You will reply there.
You DM me, like not in the group.
Okay. Okay, sir. Okay, thanks.
Okay. Okay, so in C++ there in C and in C++ we have this null macro which defaults to 0. So in some places it causes a confusion. So that is why in C++ 11 a null pointer literal was added. So null or 0 causes confusion in following cases that null pointer can resolve. So function overload resolution and forwarding templates. So the next feature that was added is inline namespaces. So inline namespaces. So in this case, what we do is that and we nest namespaces. So suppose we have a namespace called mime, and inside that namespace we are creating two more namespaces, version 98 and version 99. And one of the namespaces we call it as inline. So then what happens is that this namespace it becomes a global kind of namespace. Let us say you expand this, okay, then you will get something like this. You will get namespace mine, and then within it you will get inline namespace v99, and then you will also get namespace v98. So you have a nested namespace, but this inline namespace it will somewhat become global. You can think of it that it will become global. So inside the inline namespace we have two functions called f, and these functions will become global. It is shown here in this example. This is the default version, and we can also call old version and new version. Uh, One more feature that was added is called static assert. Uh, so you know the normal assert, okay? So within the program we can write assert, and then we can write some conditions. So the compiler will check whether the asserted conditions are correct or not, and if they are incorrect, then the program will crash with the error message. So The difference is that this assert it runs at runtime, whereas the static assert it runs during compile time. So here you can see an example. We can write here static assert and then size of long greater than equal to 8, and then uh, we can print an error message. So this checking it will be done during compile time, and if it fails then the error message will be printed. Okay, so now this is another feature, user defined literals. Okay, in some modern libraries like std chrono. Std chrono is a library for doing time related tasks. If you have anything to do with time, you will usually use std chrono. So you will see that when you use std chrono you are able to write things like this. Okay, 123 seconds. Like you can do something like this, t equal to 123 seconds. So like how is this happening? So 123, then s, so how is s becoming part of the number and how is it being interpreted? So that is how all these user defined literals are working. So these are some literals for built-in types. Okay, however in the original C++ there was no literals for user defined types. Okay, but these are some requests that the community made, that they wanted to add these kinds of literals to the types, and in C++11 this was added. So this is the way we write this. So we write a constant expression, complex double, and then operator, empty string, and then underscore literal. So then we write the underscore literal. So this can be used to add custom literals to our code. For example, see here we are defining a user defined literal like this, which is underscore s. Okay, so this takes in a string and uh, length of the string, and it requires a std string. And then you can see that here we are using a const char string. Over here we are appending, after the string we are appending a underscore s. So this automatically converts it into a std string type. So it converts it from a const char star to a std string. Okay, so these are some uses of the literals. For example, here we have again defined a complex literal which is underscore I. So now we can write complex numbers like this: 3 plus 4 underscore I, 2.3 plus 5 underscore I. We can also define units like this: underscore kg, underscore gram, underscore milligram. So then we can write 3.6 underscore kg, 2.3 underscore milligram. So we can do like this. So see, as I said that now there are very popular ones in C++. Okay, some user defined literals. So one is the string one, which converts a constant character array to a std string. Then we have seconds and hours. So these are all time units which convert these numbers to std chrono, duration, and data types. Next we have the digit separators. So this is very simple. So when we write long numbers, we can use this single quotes in between the numbers, and for readability purposes, like we can separate 3 4 digits, and it does not affect the value at all. It just separates it. It is like a comma. that we write when humans are writing long numbers, they write a comma, so it is like that. Next we have raw string literals. So this is also very simple. We know that suppose when we are writing a string, we have to escape all the special characters. Like let us say that we want to write this string slash backslash n. So what we'll have to do is we'll have to escape the backslash character. We have to write double backslash n. Okay. Now this might be cumbersome when we are writing a long string with all these special characters. Okay. So in that case, we use the raw string literal. R, uh, we write R, and then like before the string, like preceding the string, we write R. So then what happens is that the string is interpreted as a raw string literal, which means that to write backslash n, we just write backslash n. We don't have to escape the backslash with another backslash. Next one is Unicode support. Uh, so in C++11 there is support for Unicode. So there are two new character types. When we prefix a string, like when we prefix a string or a character with small u and capital U, they are created as Unicode characters. Now the normal ASCII characters is 8 bytes, whereas these are no, sorry, the normal ASCII characters, they are 1 byte, 8 bits. Now these are 16-bit and 32-bit character types, so they can store Unicode characters, which means that they can store all these like other than English, all these characters. So you can use it in your code if you want. Next we have this memory alignment function. So we have align off and align as to support the and control the memory alignment. Um, the line of keyword can get a platform dependent value of type size t to query the alignment of the platform. Okay, these are some like I'm not going over these topics. Let me go over the std move and then I will conclude it.
Excuse me, sir.
Hello, who was it?
Yes, sir. Sir, is there any WhatsApp group where you provide information?
Yes, there is a WhatsApp group.
Or could you provide the link in the chat?
Okay, okay. So now I'll go over std move. So this is very like I'll just explain the basics. So when we write something like this, when we write w2 equal to w1, the W1 is copied into W2. Whereas when we write it like this, W4 std move W3, then the W3 state is moved to W4. So in a way, uh, so as you can see from the diagram, when we write, we have a W1 which has W1 state, and then we have W2 which is a copy of W1 state. Whereas when we use std move, then the contents are moved. So in a way, it is somewhat like a pointer. So W4 points to W3 state. So that is the basics. So today we don't have time, so maybe I'll do it in the next one. Okay, so thank you everybody for attending today's session. So I am concluding the session.